I'm Rajendra Bade, and in this video, you will learn sections of solids, cubes, and tetrahedrons. Now read this problem. A cube has edges 50 millimeters long. First of all, try to understand what is a cube. A cube is nothing but a square prism that has length of base edges equal to length of face edges. We have already solved problems on prisms. So exactly in that manner, you can solve problem on cubes. Now, in general, a square prism has 4 edges at base, 4 edges at top, and 4 vertical edges. So altogether, a square prism has 12 edges. A cube has 12 edges, but all those 12 edges are of same length. In this case, length of edges 50 millimeters. One more thing, in case of a cube, since all edges have same length, to describe size of a cube, base edges, face edges, such a differentiation is not done. What is position of the cube? Let's check. It has a face in the HP. So one surface of this cube is in HP. We consider that surface in HP as base. And now you can say base is in HP. And when base is in HP, true shape of base appears in the top view. So we are going to draw true shape of base in the top view, and since it is a cube, true shape of that base surface is square. So we are going to draw that square in the top view, means below XY line. Vertical faces. Now listen, vertical faces appear lines in the top view. If a surface is vertical, it appears line in the top view. So these 4 vertical faces we must draw equally inclined to VP, means equally inclined to XY line, that is at 45 degrees. So how to draw true shape of base with all edges equally inclined to XY line? Try to understand. So here first of all XY line. Then at any convenient distance from XY line, draw a line parallel to XY line. It is simply a construction line. Identify a point, and with reference to that point, draw 2 lines at an angle 45 degrees. These are 2 of the edges of that square. Now with the same length 50 millimeters, draw intersecting arcs in this manner to complete the square. Now true shape of base, a square with all edges at an angle 45 degrees with XY line. So these edges, these 4 lines of the square are not simply edges of the square, but these are 4 vertical faces appearing lines in the top view. Now let's label all these corners as usual. A, B, C, D. These are base corners. It is a prism. So identical square at top. So label these 4 corners again with numbers. So square base ABCD, square top 1, 2, 3, 4. And height doesn't appear in the top view. So let's draw front view. Projections from all 4 corners as usual. As usual, label all base corners on XY line. It means base ABCD is on XY line. Now what is height of this prism? This prism is special. It's a cube. So length of base edges equal to length of face edges. So length of base edges is 50 millimeters. So length of face edges, that is nothing but height of cube, is also 50 millimeters. Measure 50 millimeters and draw top surface 1, 2, 3, 4. So this is how 4 base corners, 4 top corners, front view of this cube is complete. Now check whether side view is asked. Draw sectional side view. Yes, you are asked to draw side view. So let's draw side view. As usual, 45 degrees line. Transfer all these corners in the side view as usual. From front view, draw horizontal projectors. And ABCD, these 4 corners at the base, 1, 2, 3, 4, these 4 corners are at the top. One more thing I would like to tell you. A cube is also known as hexahedron. Hexahedron because it has 6 sides, 6 surfaces which are identical squares. So all 6 faces of cube are squares, identical squares, That is why a cube is also known as hexahedron. Remember this. Now let's focus on position of cutting plane. It is cut by a plane perpendicular to the VP and inclined to the HP by 35 degrees. So the cutting plane is perpendicular to VP, so it should be a line in the front view. The line must be at an angle 35 degrees. So cutting plane line we are going to draw at an angle 35 degrees. The cutting plane cuts the left vertical edge at 10 millimeters above the HP. Cutting plane cuts the left vertical edge. So there are 4 vertical edges, A1, B2, C3 and D4. C3 is left vertical edge. So cutting plane line must cut this edge 10 millimeters above the HP. So proceed. Measure 10 millimeters from HP. Get the point on the left edge. And through this point, we'll draw the cutting plane line at an angle 35 degrees. So this is how cutting plane line at an angle 35 degrees, cutting left edge 10 millimeter above HP. Now listen. Once you have located cutting plane line, remaining procedure is same in all the problems. Just follow the procedure. Label points of intersection of cutting plane and the edges. When cutting plane intersects face edges, label those points with letter P. And when cutting plane intersects top edges, it intersects 2 edges at top, label those points as S and T. And when cutting plane intersects base edges, in this case it is not intersecting base edges, but when cutting plane intersects base edges, label those points as U and V. So let's label points of intersection of cutting plane and edges. So PC, PB, PD and S and T. Simply transfer these points in the top view. PC on edge C3, PB on edge B2, PD is on edge D4 and S and T, these 2 points are on the top surface. So this is how we got all 5 corners in the top view. Now transfer these points in the side view. So PB and PC and also PD will transfer by horizontal projectors from front view to side view. So this is how PB, PD and PC. S and T you will not able to transfer properly. Reason is you don't get sharp intersection in the side view. So we'll take help of top view to transfer points S and T. So this is how we'll get S and T in the side view. So all 5 corners in the side view. So join these points to form a closed polygon. In the side view also join these points to form closed polygon. So this is how section in the top view, section in the side view and also section in the front view are complete. Section in the front view is simply a line. Watch, PC to S and T, PC to ST. This overlap of cutting line on front view, that is section in the front view which appears line. And section in the top view, a pentagon. Section in the side view, a pentagon. Of course, not regular pentagon. Now remaining procedure, hatching lines in the section and to make a retained portion dark. So this is how, as usual, draw cutting plane line which is front view. So it should be above XY line, and when front view parallel, then top view gives a true shape of the surface. This is final drawing. Remember, in your final drawing, all information in the problem, that is edge is 50 millimeters long, edge is 50 millimeters long. So base edge is 50, face edge is 50, cutting plane is 35 degrees inclined, it intersects left side edge 10 millimeter above HP. All given dimensions you must insert in your final drawing. Read the problem. A cube of solid diagonal 80 millimeter is resting on HP with its 4 vertical faces equally inclined to the VP. Now 4 faces are vertical. It means a face is in HP and a face top parallel to HP. So altogether there are 6 surfaces. Of course, the face which is in HP will assume it as a base. So automatically there will be 4 vertical faces, and these 4 vertical faces appear line in the top view. So we are going to draw true shape of base, that is nothing but face in HP with edges 45 degrees inclined to XY line. So position is similar to the last problem. But something new in this problem. A cube of solid diagonal 80 millimeters. What is solid diagonal? So try to understand. A cube is a very standard shape. If we imagine a line from a corner at the base to the diagonally opposite corner at the top, length of that imaginary line is 80 millimeter in this case. That imaginary line is called solid diagonal. Remember once again, if we imagine a line from a corner of a cube, from base corner of a cube up to the top corner, which is diagonally opposite, that line is called the solid diagonal of the cube or body diagonal of the cube. And this body diagonal length is related with length of edges in this manner. Length of edges of a cube is equal to length of solid diagonal divided by root 3. As I have already told you, solid diagonal is also called as a body diagonal of the cube. Length of body diagonal divided by root 3, that is length of edges of the cube. In this case, solid diagonal is 80 millimeters divided by root 3, and it is 46.18 millimeter. Now remember, these videos I am making for the students who are going to draw manually this drawing in their exams. Remember, the drawing instruments we use to draw this drawing have least count 1 millimeter. We cannot measure less than 1 millimeter using those drawing instruments we have in our compass box. Therefore, we are going to measure 46 millimeters as edges of this cube. So let's proceed. True shape of base in the top view. Don't label center of the square because it is not square pyramid. It is square prism. Remember, cube is square prism that has length of base edges equal to length of face edges. So like in the last problem, you complete top view, then front view and side view of the cube. Now once you have completed the required 3 views, remember, don't make any single line dark at this stage. In case of sections of solids, without cutting the object, you should not make any single line dark. So let's proceed for the cutting plane. With its 4 vertical faces equally inclined to VP. Okay, it is cut by an AIP. Now try to understand. Of course you know it, AIP, auxiliary inclined plane. It is a plane inclined to HP and perpendicular to VP. So we are sure that cutting plane line is in front view. It is cut by an AIP in such a way that true shape of the section is a regular hexagon. Remember, here location of cutting plane, position of cutting plane we are going to choose for required section. We want section a regular hexagon and we are asked to choose cutting plane line. So how we should go about it, try to understand. If we look at cutting plane line in this manner, then cutting plane line will cut top edges. So 2 corners at top edges as usual, S and T. And here cutting plane line cuts of face edge. So this point is PC. So we'll get 3 corners. That is, section will be a triangle, not a hexagon. Now if you want equilateral triangle, isosceles triangle, then you may use this cut. But in this problem, this cut is not appropriate. Then is it okay? Let's check it. S and T, you will get 2 corners at top. U and V, you will get 2 corners at base. So if you choose cutting plane line in this manner, the section will have 4 corners. No, this is not the right choice. Then watch here, 2 corners at top, here 2 corners PB and PD, and here a corner PC. You'll get a pentagon similar to the last problem. We don't want pentagon. Then how you should choose a section? Let's check it. Here PA, PB and PD and PC. There will be 4 corners. This section will be a rhombus. We want section a hexagon. So there must be 6 corners. Is it okay? Let's check it. S and T at top, U and V at base, and here PB and PD. Yes, we are getting 6 corners. So that means the cutting plane line we are choosing should cut top edges, base edges, and middle to vertical edges. But we don't just want a hexagon. We want a regular hexagon. So this cutting plane line we should choose very carefully. Some of you must have guessed it. Since all surfaces are identical, all edges are of same length, if this cutting plane line cuts these are 6 edges, 2 edges at top, 2 edges at bottom and 2 vertical edges. If this cutting plane line cuts these are 6 edges exactly at their midpoints, then we'll get the regular hexagon. How to achieve it? Now watch here. Cutting plane line should cut edge 1, 2 and also edge 1, 4 at midpoint. How to get midpoint of this edge? There are two ways. Either you bisect 1, 2 using regular procedure, that is intersecting arcs at top, intersecting arcs here on this side. You will get perpendicular bisector and therefore midpoint. But there is one more way. Edge 1, 2, we don't know length of edge 1, 2 in front view. But in the top view, we know this length, it is 46. In the top view, the same edge 1, 2, here it is 1, 2, it is giving true length. So here we can measure 23 millimeters to locate midpoint. So this is how. And this midpoint we can transfer here in the top. So this is how, this is the point S and T, that is cutting plane should cut top edges at this point. Similarly here also, at the base, BC and CD, these two edges, cutting plane should cut at their midpoints. So get midpoints from top. So measure 23 millimeters and 23 millimeters on these two sides on that edge, so that you'll get midpoint. So this is the point which is center of these two edges, midpoint of these two edges, transfer it in the front view. So V dash and U dash, this is how you'll get 2 points here. Now through these 2 points, draw the cutting plane line. So check now, clearly cutting plane is intersecting all these edges at their midpoints. Here 2 corners S and T, here 2 corners U and V, and here 2 corners PB and PD. And the problem is as good as solved. Remember position of object and position of the cutting plane. These are two very important steps. Now we have these 6 corners, transfer it in the top view, transfer it in the side view. S and T, here you will get those 2 points. U and V, here you will get those 2 points. PB and PD. PB is on edge B2 and PD is on edge D4. So this is how you will get all 6 corners in the top view, join and draw hatching lines. This is section in the top view. It's a hexagon. Here also, PB and PD you will transfer by drawing horizontal projector in the side view. PB is on edge B2, PD is on edge D4. S and T and also U and V you should transfer from top view to side view. So this is how you will transfer these points in the side view. So sectional side view is over, sectional top view, make retained portion dark of course. Check here on the right side of ST, retained. So this is retained side. Left side of UV, left side is removed. Portion in which corner C is removed portion. So this is removed portion. Portion in which corners A and 1 are, that is retained portion. In this case also, portion that contains corner B is a retained portion. Check here, B is retained portion. D is on the retained portion. Check here. The view in which cutting line, that gives you clear idea about retained and removed. So this is how sectional top view is complete, sectional side view is complete. Draw cutting plane line parallel to XY line and complete the true shape. Watch here. True shape of the section is a regular hexagon. So this is how we have achieved the true shape of the section. Final drawing means you have inserted all dimensions. Now try to understand. Length of edges are not given, but body diagonal is given. Given dimensions you should insert in the diagram. So a corner at base, that is corner C, and diagonally opposite corner at top, that is corner 1. This length is 80 millimeters. Length of solid diagonal is 80 millimeters. Remember, solid diagonal is an imaginary line. It is not edge of the object. So you must not make this line dark. If you make solid diagonal dark, you will lose marks. Remember. So this is how we have completed the drawing. Have you realized once you have located the cutting plane, the remaining procedure is same in all the problems. So give more importance to initial position of object and cutting plane. And remaining procedure remains the same in all the problems. Simply follow the procedure. Now read this problem. A cube is cut by an AIP, auxiliary inclined plane, plane perpendicular to VP. So cutting plane line is in the front view. In such a way that true shape of the section is a largest possible rhombus. Length of the edges of the cube is 50 millimeters. Draw sectional front view, sectional top view, and true shape of the section. So largest possible rhombus. For rhombus, we are going to locate the cutting plane. How to achieve that? Listen. Draw front view and top view of a cube resting on HP. Now we know that if cutting plane cuts base in this manner, horizontally, then true shape of section is square. If we draw cutting plane slightly inclined, when it cuts only face edges and all the four face edges, then you will get a rhombus. Now, if you go on increasing inclination of that cutting plane, length of longer diagonal will go on increasing. So largest possible rhombus, that is when cutting plane line passes through corners C and 1. If you still increase the inclination of cutting plane, then you will get a regular hexagon. Then you will get hexagon. We don't want hexagon, we want rhombus, and that too largest possible rhombus. So cutting plane line must pass through corner C dash and corner 1 dash. So this is how cutting plane line we have located. 4 corners PA here. Cutting plane line intersects edge A1 exactly at point 1. So this point 1 is nothing but point PA. Here PB and PD, and here PC. So this is how we'll get 4 corners, and proceed as usual, and true shape of base you will get a rhombus. Now read this problem. A cube is cut by an AIP, that is cutting plane line, in the front view in such a way that true shape of the section is largest possible equilateral triangle. That means it should have 3 corners only. Length of the edges of the cube 50 millimeter. Draw sectional front view, sectional top view, and true shape of the section. So you are not asked to draw sectional side view. So we'll draw only front view and top view of the cube. Now check here. If cutting plane line is oriented in this manner, section will be a triangle. We want largest possible equilateral triangle. So if a line passes through the corner 2, 4 and corner C, you will get a triangle because there will be 3 corners here, S and T. This points S and T will coincide with 2 and 4. And one point here, PC. Cutting plane intersects vertical edge exactly at point C. So this is PC. So S and T means corners 2 and 4. And PC means corner C. So you will get section with 3 corners. As usual, you proceed and draw true shape of the section, that will be largest possible equilateral triangle. Because if you draw cutting plane line very close to 3, it will be a section triangle but smaller triangle. If you go on increasing distance of cutting plane line from corner 3, then the true shape of section will be triangle and bigger triangle, and again more larger triangle if you go on increasing the distance from corner 3. But you cannot have distance more than this, because if you further move this cutting plane away from corner 3, then it will be pentagon or hexagon. So this is the limiting position of cutting plane that will give you a triangle. So you will get largest possible equilateral triangle. Now let's read this problem. Cube is cut by an AIP in such a way that true shape of the section is a rhombus of longer diagonal 80 millimeters. Length of the edges of the cube is 50 millimeters. Draw sectional front view, sectional top view, and true shape of the section. Okay, so let's draw front view and top view of the cube. In this position, horizontally if you cut it, it is square. Slightly inclined you will cut it, you will get a rhombus. Earlier one problem we found out position of cutting plane for largest possible rhombus. In this case, we want a rhombus with longer diagonal 80 millimeters. So how to achieve that? Simple. Cutting plane line must have its overlap on the front view 80 millimeters, and you can achieve it in this manner. Take corner 1 as center and distance 80 millimeters in compass, and cut the left side edge. This is the point through which cutting plane should pass, and point 1 through which the cutting plane should pass. And this is how the cutting plane position is. four corners PC, PB, PD, and here PA, because it is cutting vertical edge A1. So that corner PA is nothing but corner 1, but you label it better as PA. So you will able to identify it as corner of the section. So PA, PB and PD and PC. And as usual, you proceed, you will get a rhombus of longer diagonal 80 millimeters. I did not explain you further because it is the same procedure which we have used in all other problems. Once you have located cutting plane, simply label points of intersection of cutting plane edges and transfer those points in other views and also for the true shape of the section. Now read this problem. A cube is cut by an AIP in such a way that true shape of the section is a trapezium with parallel edges 30 mm and 60 mm long respectively. Length of the edges of the cube is 50 millimeters. Okay, first of all, draw views of the cube in this manner. Top view and front view. So like earlier problems, draw views of the cube. And for trapezium, it must have two edges parallel to each other. So if one edge at top and the other edge is at bottom, out of those two parallel edges, one is at top, one is at bottom, then you will get a rhombus. Rhombus has four corners, so you must have only four corners. So cutting plane should cut top edges and bottom edges only. Now how to get exactly 20 millimeter, how much is that? 30 millimeter and 60 millimeter long edges, try to understand. Measures symmetrically 15 and 15. So this is how you will get length UV exactly 30 in the top view. UV, these 2 points are on the base. Now measure 30 and 30, that is 60. So S and T, this length ST in the top view, you will get exact 60 millimeters. So these are two parallel edges and these are four corners of the section. If you join these four corners in the top view, you will get the trapezium with parallel edges 30 and 60. Now transfer points UV and ST in the front view. So here U dash and V dash and here S dash and T dash. So cutting plane must cut top surface at this point S dash T dash. And cutting plane must cut base surface at these 2 points U and V. So this cutting plane line gives trapezium, parallel edges 30 millimeters and 60 millimeters. Now as usual, draw sectional front view, that is make retained portion dark, make here retained portion dark. S, U, V, T and V, these are the points, corners of the section. So join these corners to form a closed polygon, it will be a rhombus. And then make cutting plane line parallel to XY line and complete the rhombus, that is true shape of the section. Now let's read this problem. A tetrahedron of edges 60 millimeter. First of all, do you know what is a tetrahedron? So listen, we have already solved in my first video on sections of solids. We have solved problems on pyramids. A tetrahedron is nothing but a triangular pyramid. So 3 base edges and 3 inclined edges from apex called face edges. So overall 6 edges. It is a triangular pyramid, that means a triangular base and 3 triangular faces. So altogether there will be 4 surfaces. Now it is a pyramid, a triangular pyramid. Then what is special about it? So try to understand. A tetrahedron is a triangular pyramid that has length of base edges equal to length of face edges. Since all edges are of same length, like a cube, in tetrahedron, base edges, face edges, such a differentiation is not made while describing size of a tetrahedron. A tetrahedron of edges 60 millimeters, so you can solve this problem considering it as a triangular pyramid, length of base edges 60 millimeter and length of face edges also 60 millimeters. Okay, let's proceed. A tetrahedron of edges 60 millimeter long has one of its faces in the HP. All faces are triangles, equilateral triangles, since all edges are of same length. So this object has 4 equilateral triangular surfaces, and that is why it is called as tetrahedron. A tetrahedron of edges 60 millimeter long has one of its faces in the HP. So one face in HP. Of course, that face we are going to consider as base. Base is equilateral triangle. One of the edges of the face in the HP is parallel to and nearer to the VP. In this position, the tetrahedron is cut. Okay, we'll talk about cutting plane little later. First important step is position of object in given position. We should start with true shape of base. Base is in HP. Of course, the face which is in HP, we'll consider it as base. Remember, all surfaces in tetrahedron are identical equilateral triangles. Therefore, while describing a tetrahedron, base and face, such a differentiation is not made. All surfaces are called as faces. Okay, so one face, that is nothing but we'll consider base. Base in HP. So true shape of base below XY line, that is in the top view. So here we are going to draw true shape of base, that is equilateral triangle. But how we should look at that equilateral triangle? Its orientation. One of the edges of the face in the HP is a parallel to and nearer to VP. So face in HP, that is nothing but base, and one edge of the base is a parallel to VP. Top view gives details with respect to VP. So that edge must be parallel to XY line in the top view. So you draw first that edge, 60 millimeter long base edge, and then complete the equilateral triangle. So this is how, as usual, you should complete equilateral triangle. This is true shape of base. Label all the corners. Now it is not a prism, it is pyramid. Tetrahedron is triangular pyramid. So it has apex, and that apex coincides with center of base in the top view. That is why we should locate center of base. So join a corner with midpoint of opposite edge. So join any two corners with midpoint of corresponding opposite edges and you will get the apex. Now join that apex with all base corners. So OA, OB and OC. These are all face edges in the top view. So 3 base edges and 3 face edges. OA, OB and OC are face edges. Now transfer all these points in the front view. So A dash. Two views of a point lie on same projector. So A dash, C and C dash, B and B dash. All 3 base corners we have marked on XY line. That means this surface ABC is on HP. We want one face in HP. Okay. Now apex. How to mark apex? And this is very important. If you know height of a solid, you should measure that height vertically. If you know length of axis of the solid, then you should measure it vertically. When base is in HP, you should measure length of axis also vertically. But in this case, length of axis is not given, length of face edge is given. Now which are the face edges? OA, OB and OC. But edge OB, check. From top view, it is top view gives details with respect to VP. Remember, from top view it is clear that edge OB is not parallel to VP, and that is why O dash B dash must not be true length. That is, you cannot draw O dash B dash 60 millimeter long. That is mistake. In projections of lines, you have studied that if top view is parallel, front view gives true length, and if front view is parallel, then top view of that line gives true length. Now I am asking you here, which face edge? Remember, there are 3 face edges, OA, OB and OC. Which face edge is showing true length in the front view? What you are going to check? If you want to know details with respect to VP, top view you should check. OA, it is not parallel to XY line. So front view is not true length. OB is not parallel to XY line. And OC is also not parallel to XY line. So no face edge is showing true length in the front view. Then how to locate apex in the front view? Listen me very carefully. What we have studied in predictions of lines, if top view parallel, front view is true length. So make top view of any one of these 3 face edges parallel to XY line. How? Watch carefully. So edge OB, we have rotated about point O. So OB, top view of edge OB, we have made it parallel as OB1. So if OB1 is a parallel to XY line, then O dash B1 dash, front view of OB1, O dash B1 dash is true length. So we'll transfer B1, B dash and B1 dash on same horizontal line. So here it is B1 dash, and from B1 dash, now you will cut projector of apex using true length, and that is 60 millimeters. Take 60 millimeter true length, cut the projector. So this is how you will get apex in the front view, O dash. O dash B1 dash is true length. O B1 parallel, O dash B1 dash is showing true length. Of course, don't make O dash B1 dash dark. It is not edge, it's simply construction work. Edge in the front view is O dash B dash and not O dash B1 dash. So join apex with all base corners and you'll get three face edges in the front view. So O dash A dash, O dash B dash and O dash C dash. These are the three face edges in the front view. Remember, there are chances of mistakes. Many students make mistake. There are students measuring 60 millimeters vertical. I've seen students measuring B dash O dash 60 millimeters. But remember, in case of pyramids, when length of face edges is known, you will have to check which face edge is a parallel to front view so that it shows true length. If no face edge is a parallel to VP, then make one of the face edges parallel to VP. And how to make that? Make top view parallel to XY line in this manner. Okay, now check whether side view is asked. If it is, you should complete the side view also. You are asked to draw sectional side view. So let's draw side view. As usual, draw 45 degrees line, horizontal projectors from all corners, from front view to side view, and projectors from top view to side view, as usual. So A double dash, B double dash. Now A double dash, B double dash, side view of points A and B coincide, and side view of point C. Join apex with all base corners. So these are the three edges, OC, OA and OB coinciding here. Here it is axis of the pyramid, that is this tetrahedron. Axis here coincides with edge OC. When axis coincides with edge, then edge is important, not axis. So here we should not draw axis, but we should show edge OC. Here we could show axis. So front view, top view and side view are over. Now let's locate the cutting plane. In this position, the tetrahedron is cut by an AIP. So it is cutting plane in front view, inclined to the HP by 30 degrees. Okay. So we should draw that cutting line inclined at 30 degrees. The cutting plane passes through the left side corner of the solid. The cutting plane should pass through B dash. Let's look at the cutting plane. So through B dash at an angle 30 degrees, we have drawn this cutting line. And problem is as good as over. Where cutting plane intersects edges, label those points as usual. So O dash A dash, here it is point PE, here it is point PC, and here it is point PB. That point PB is nothing but point B because cutting plane intersects edge OB at point B. So label those points. And here it is PB. So section is a triangle with these three corners, PA, PC and PB. Let's proceed. PA on edge OA, PC on edge OC and PB is exactly at point B. So here it is PB. Similarly, these three corners in the top view. So PA on edge OA, PA, PC on edge OC. Do you remember the procedure how to do this? When an edge appears vertical in front view, top view, then a point on that edge to be transferred using a special procedure. What is that? You must be knowing that. In first video on pyramids, we have discussed about it. Watch here once again. PC transfer it on boundary edge OA. Then project it on boundary edge OA in the top view. Top view edge OA is here. And then use compass and OS center, transfer it on its own edge again OC. This is that procedure. But if you have already PC in the side view, you can transfer it from side view also. Here we'll prefer side view, and this is how I have transferred PC. So we got PA, we got PC, and PB is point B only. So this is how three corners in the top view. Now join these three corners to form closed polygon, of course, triangle. So this is how we have joined these points. Hatching lines, it is newly generated surface. Here it is triangle again. Now retained portion, you know the view in which cutting line is, that gives you clear idea about removed portion is a portion closer to XY line, and retained portion, removed portion is portion closer to observer, and retained portion is portion closer to XY line. Here it is. Watch here. Portion containing apex is removed portion, and portion containing base ABC, that is retained portion. So this portion is retained, this portion is removed. Here also
Watch here. A is on retained side. So this C is on retained side. So entire base is retained. So ABC is retained. And PA to A, that is retained portion. So take help of this view to identify retained portion in the top view and side view as usual. And now make cutting plane line parallel to XY line. And from adjacent PA, PB, and PC. This is how you draw projectors, and front view to top view vertical projectors, and there's true shape of the section. Final drawing, that is insert all dimensions. So cutting plane inclined at 30 degrees. True length, watch here, 60 millimeter is length of face edges, but how we have inserted a dimension. Watch here, this true length construction line we have drawn, that is dimensioned as 60 millimeters, and here length of base edge is 60 millimeters. So this is how final drawing is complete.
Now read the problem. A tetrahedron has one of its faces in the HP and an edge of the face perpendicular to the VP. In this position, it is cut in such a way that true shape of the section is a square. Draw sectional front view, sectional top view, and true shape of the section. Take edges of the solid 65 millimeters long. Now let's focus on position of object. A tetrahedron has one of its faces in the HP. Tetrahedron has 4 faces. All are equilateral triangles. The face in HP will assume it as base of the object. So base in HP, that means true shape of base in the top view. Edge of the face, that is the face in HP. Edge of the face perpendicular to the VP. So when you draw true shape of base, that is equilateral triangle, you should draw one edge perpendicular to XY line. Let's proceed. So here it is XY line. This is that one edge of the base which is perpendicular to VP. Here we are drawing top view. Top view gives details with respect to VP, and that is why in the top view one edge is perpendicular to XY line. It means that edge is perpendicular to VP. Now complete true shape of base. So as usual, an equilateral triangle of side 65 millimeters. This is true shape of base. Label all corners of base A, B, C. Now, tetrahedron is a pyramid. It has apex. In the top view, apex coincides with center of base. So let's locate center of this triangle. So join a corner with midpoint of opposite edge. Use one more corner, join with midpoint of corresponding opposite edge. So this is how you have located apex. Now join apex with all base corners. Those will be face edges in the top view, OA, OB, and OC. So now the top view is ready. Now transfer all these points in the front view. A dash, B dash, and C dash. This triangular surface is on HP, on XY line in the front view. Now let's transfer point O. Draw projector. So O is on this line. Now what is length of face edges? Remember, when length of face edges is given, check which face edge is showing true length in the front view. If top view parallel, then front view true length. So check OA, OB, OC. These are the 3 face edges. OA, this edge has its top view parallel to XY line. It means front view of this edge shows true length. So from A dash, use the 65 millimeter true length of edge and get apex. So this is how we have located apex in the front view. Now join apex with all base corners. So OA, OB, and OC. OB and OC are coinciding here. And here it is axis of the pyramid. Okay. So this is how front view and top view are over. Now let's check whether side view is asked. Draw sectional front view, sectional top view, and true shape of the section. Okay. Side view is not asked. So that's position of object. So views of object in given position, and now let's locate the cutting line. In this position, it is cut in such a way that true shape of the section is a square. So now true shape of the section is given and we are asked to locate the cutting plane. Now if we draw cutting plane in this manner, is it possible that we'll get a square or at least a shape with 4 corners? Let's check it. Here you will get a corner, and that is PE. You will get two more corners for the section, PB and PC. So you will get a section that has three corners. It means section is a triangle here. So this cutting plane line is not correct. Then, is it okay? Let's check it. Here we get a corner, PA, and here get two more corners, and those corners are U and V. So again, section will be a triangle. So you should not choose cutting plane line in this manner. We want, first requirement is four corners. Let's check for four corners what should be the orientation of cutting plane line. If we draw cutting plane line in this manner, then here you will get PB and PC, two corners, and here U and V, two more corners for the section. So if cutting plane is oriented in this manner, it will cut four edges, two face edges and two base edges, and there will be four corners to the section. So this orientation is correct, but exact position for square. I think some of you must have identified the cutting plane line position. I give you a hint. In one of the earlier problems on cube, we have cut the cube for regular hexagon. It is the same logic to be used in this case. Since all faces of a tetrahedron are identical equilateral triangles and all edges are of same length, if cutting plane intersects all these four edges, means two face edges here and two base edges here. If cutting plane line cuts all these edges at their midpoints, then we'll get the section, a square. So how to get those midpoints? So OB, OC. How to get this midpoint? So simply bisect this side. Bisect as usual. Draw intersecting arc on this side. Draw intersecting arcs on this side. And get the midpoint. So here it is midpoint of edge OBOC. Similarly, watch here. A small red point. Get midpoint of edge AB. You don't know length of this. So bisect this and get that midpoint. Once you get midpoint of these edges, draw cutting plane line through these midpoints. So this cutting plane line will give you not just four corners but exact square. This is a removed portion because for sectional top view, observer is watching from top. So section must be visible from top. So portion nearer to observer is to be removed and portion closer to XY line is retained. Now label these points UV at the base, PV, PC, as usual transfer. As usual, draw cutting plane line parallel to XY line and get that true shape. You will get it square. Now read this problem. A tetrahedron, edge 60 mm long, has one of its faces in the HP and an edge of the face perpendicular to the VP. So position of the object is similar to the last problem. In this position, it is cut in such a way that true shape of the section is a trapezium having parallel edges 30 mm and 40 mm long respectively. Okay, let's focus on the position of the object, and it is similar to the last problem. So use that procedure and complete front view and top view. Side view is not asked. So front view and top view. Now it is cut in such a way that true shape of section is a trapezium. Is it okay? So you will get two corners here and two corners here. Yes, it seems correct position, correct orientation. Now position, how to choose? Let's check it. Remember, if you cut it in this manner, you will get 2 points here, PB and PC. If you project, you will get PB on edge OB and PC on edge OC. Now listen what I am telling you. PB and PC coincide here in the front view. So PB and PC on the same projector here in the top view. So line PB PC will be vertical in the top view. Similarly, U and V coincide here. If you project U and V in the top view, U on edge AB and V on edge OC, U and V on the same projector, it means it will be a vertical line here. Now UV and PVPC, these two lines will be parallel to each other. And these two lines are nothing but edges of the section. So section has these two parallel edges, UV and PVPC. And these two parallel edges must be 30 and 40 mm long respectively. So to get these exact lengths here in the top view, How to locate the cutting plane? Try to understand. Draw axis of symmetry. Measure 15 millimeters and 15 millimeters symmetrically. So overall 30 millimeter length we have measured symmetrically. Transfer on base edges for points U and V. So if you join U and V, length UV will be 30 millimeters. So if you want length UV 30 millimeters, U dash and V dash 20 millimeters and 20 millimeters here we have measured symmetrically for PB and PC. PB is on edge OB, PC is on edge OC. And if you join PB and PC, it will be 40 millimeter long. Now, to get PB and PC 40 millimeter long, project PB and PC in the front view, U and V in the front view. So U and V on the base, PB and PC on corresponding edges, PB, PC coincide here, U and V coincide here. To have PB, PC 40 millimeters long in the top view, cutting plane should cut these two edges at this point. And to have UV 30 millimeters long, cutting plane must cut base at this point. Now locate the cutting plane. This is the cutting plane line. Portion nearer to observer, that is the apex side portion, is the removed portion. And here it is retained portion. Make retained portion dark. These points, 4 corners are already there in the top view. Join these 4 points, you will get a trapezium with parallel edges 30 and 40 millimeters long. And as usual, draw true shape. Make this line parallel to XY line and complete true shape in the top view. Thank you for watching the video. We'll meet soon in my next video. Till then, bye bye.